Our next speaker will be Alex Giladi from Comcast. He's a principal architect there. And his theme is, does capping the encode bitrate really cap streaming quality?
Okay, so I'm Alex Giladi, principal architect in Comcast, and thank you for staying here that late to attend this talk. So, despite the very lengthy question, the talk is actually pretty simple. Rate constancy versus quality constancy in case of adaptive streaming. Okay. I don't think that it switches. It does, okay. Anyway, so a very quick primer on adaptive streaming. So you have your normal regular source like you had for decades, a live feed or a MES file. You feed it into a multi-rate encoder. You get several outputs. All outputs are perfectly time aligned. They differ in bit rates, they differ in resolutions, sometimes they differ in frame rates. In Dash terminology, which I personally prefer, these are called representations, and since they have exactly the same content, they are mutually switchable at will, and you call this group adaptation set. Now, out of the encoder, you have several lined elementary streams going to the packager. The packager creates segments, being playable chunks of video, something like 2 to 10 seconds, and more importantly, a manifest which lists all the segments, where to get them, lists all the representations, what they are, what are the bit rates, and so on. Then all of this is getting published through the origin to the CDN. You end up with a multitude of segments and a manifest. On the client side, you have a player that has an internal buffer. It gets a manifest. It sees what is the representation that it can sustain and it can play. It starts downloading segments from it. It downloads into the media buffer, and it plays out segments from the media buffer. And same as in the VBV model, if your buffer runs empty, you crash and burn. So some amount of terminology. So first of all, ABR, adaptive bitrate, horrible misnomer. It's actually called adaptive streaming over HTTP. CBR, what we have been doing in the industry since 90s. In case of adaptive streaming, you keep your segments roughly the same size. True VBR, you give your encoder any budget. It can spend any bits, any amount of bits that it wants, as long as the quality is constant. So capped VBR is how this is actually implemented in real life. You cannot really implement unlimited buffers. So you typically limit the bit budget to a certain maximum. You have a coded picture buffer, and then you have an average rate that you are asking your encoder for, and a peak rate that, for instance, can be 200% of. Now, there are two things that are a bit newer than these and are gaining popularity. So first of all, typically what you have is an encoder operator that has a document listing resolutions and bit rates. The operator puts the resolution and the bit rate, and off you go with the encode. Now, this is not necessarily needed in case of adaptive streaming, because you don't have a pipe, you don't have a real pipe you need to fit into, and you can go and do per title optimization, and you can encode every piece of content at a bitrate ladder that makes sense for this content, and we'll discuss it later in more detail. So, lastly, context-aware encoding, something very exciting and just starting. Your viewing environments can differ. You are able to distinguish far more when you're in this room and under these lighting conditions, and you have this side of the screen than if you look at your phone and you are in a lighted space. So there are a lot of interesting optimizations that can go into the actual context in which you are viewing whatever content that we're trying to provide. So, going to the last 2 points, to things that depend on content. You always have different complexity in different natural content. So let's draw a very simplistic ray distortion curve. Ray distortion curve is how much bitrate-wise would it cost you to maintain quality X. So let's say we have segment 1. It's relatively simple, and the line shows you how much would it cost you to get to a decent quality. Here we have a more complex segment from the same content, and there it costs us way more bitrate-wise to get to the same quality. So the way we typically treat this situation is allocate exactly the same amount of bits for both segments. So as you can see, you'll get segment 2 at a lower quality than segment 1. A dual approach is to go for consistent quality and allocate as many bits as you need to get to a certain quality target. So instead of roughly constant bitrate, you get to roughly constant quality. And let's try looking at this over time. So we're trying to look at segment sizes and the resulting quality over some time. So CBR, we're trying to provide equal amount of bits. Everything has pretty low bitrate variation, but this comes at a price. The price is low quality at the difficult content. And when you have badly encoded video, you are probably better off showing badly encoded video for the duration of the session and not doing bad than much better than again a much worse quality. So it's annoying. You don't want to do this. So capped VBR, the more realistic option. You give each segment as much as it deserves. In this graph, you actually spend exactly the same amount of bits. Doing this, you have far more variability. You have more constant quality. All great. You have to deliver it. If you are able to deliver it to a normal client, so you hit the jackpot. One note about content-based. So we just looked at 2 RD curves showing complexities of segments. Netflix here stacked together a fair amount of RD curves for different content, and what you're looking at is a very graphic way of saying you may pay more for the same quality for some content. You may pay far less for this. So you either encode everything at the same bitrate and treat everything equally this way, or you give every piece of content what it deserves. So now that we're talking about content-aware streaming, how do you actually pull this off so that it will work with different clients that exist in the wild? So let's say you had a CBR or CBR-ish encode, and you provided something that is workable at 1 megabit, 2 megabits, 3 megabits, and 4 megabits. And you have, or your client knows that the network is 2.5 megabits. So the simple client will reach the conclusion it can sustain 2. Great, it will always go and keep getting segments from representation at 2 megabits, and that's it. So same variable quality, but it's safe. The majority, unfortunately, is there. If you so then you can get gradually smarter, especially if you have additional side information being quality metric of a segment, basically average quality of the segment, and segment sizes. So if you already know this, you can go and figure out that you can actually take segments from different representations and present your user with a better quality than just going for a single representation. You need to schedule things correctly. If you are able to do a long-term schedule as the smartest client here at the bottom right, you can build a schedule that more or less emulates VBR without compromising the majority of the clients that have no idea what quality metric is, and that segments are not all equivalent. So, as we said, the most common scenario is CBR encodes, capped VBR with relatively low caps, something like 110% cap, are becoming more and more common. The best scenario is something that has a very generous cap, and this is something that is now proposed as a guideline by Apple. So if you are to go and do a deployment, you can, and you don't control your client, then you probably want to keep close to CBR, and to recommend the client, we'll talk about it a little bit later, to keep larger buffers to accommodate for VBRness. So in addition to hand waving, we tried doing some amount of tests. So we took the first 30 minutes of Star Wars and at 1080p and tried encoding it under different scenarios. So all of this uses open source X264 encoder, and all the scales here, the quality scales used RSSIM Plus, which is a proprietary quality metric that does a very good job of perceptual quality estimation. If you look at the blue line, VBR, this is X264 in the CRF mode. Your quality is fairly consistent. Your mid to low 90s. When you are operating, you always want to be above 90. The GND for the metric is about 5, so you are in a good state if you are in this area. Now capped VBR, which we emulated by setting much larger CPBs. You immediately can see that this is the orange line. You can immediately see that you're starting to pay more for harder sequences. If you go CBR, using the definition of CBR as CPB of 0.9 seconds, then you really crash and burn. And a better illustration is just zooming into the previous graph. So as I said, a rough SIM Plus developers said that the rough GND there is 5. CBR drops more than 30 points. So it's pretty steep price to pay for predictable sizes. You are in a better state in kept VBR, but still the drop is noticeable. If we go and summarize this, people typically look at the mean, and at the mean it actually doesn't matter. You are well within the GND between the unconstrained VBR and CBR. The minima are the interesting story. So on CBR, you see that the minimum is completely unwatchable at 60. The first and second percentiles, which actually matter when you have 40,000 frames, are also pretty low. And if you look at the standard deviation, it's way higher for constant bitrate, which actually makes sense. You just made bitrate constant instead of quality. So how do you deliver this thing? We already know what are the benefits: constant quality, or roughly constant quality, and better quality overall. But you have peaks and valleys because you are not constraining your bitrate. So the easy thing is you are saving the bits, storage, and transmission because your same bitrate is now top bitrate, and you just are sending less pixels. So this is great. This doesn't give any benefit to your actual viewer. On the other hand, if you are spending less bits overall for the same quality, you can give access to this higher quality content to larger share of the population who have lower available bandwidth. So for this, you need to buffer and plan ahead. How are you exactly going to sustain the bitrate? And the nice illustration here shows how buffering is defined in Dash. So you basically have a buffer time in units of time, and you have the actual amount of bytes. So you have a bandwidth that is declared for each representation, and this gives you a buffer that you can fill. So if your buffer is larger, you can survive more VBRness. If your buffer is one segment, you cannot. So let's look at exactly the same encodes and look at the variability. Obviously, we have, in case of 2-second segments here, huge peaks and nearly 13 megabits needed to download content that actually averages at 3.9 megabits. If you go to slightly larger segments, 10 seconds, you are already reducing your peaks. And if you look at the CBR and CBR here, you see that CBR and constant VBR become far more predictable, which brings us to a very simple chart. What if you buffer longer? So if you buffer for 10 seconds, you need 10.5 megabits to sustain the variable bitrate presentation. If you go to 30 seconds, all of a sudden you are below 7500. Same amount of bits. Why does it matter? It matters because if a good portion of your audience has 9 megabits available, all of a sudden you are actually able to show better quality to a larger portion of your audience. Now, in terms of MPEG DASH, it has a fair amount of interesting features that can help you survive variable rate content. So the first thing, which we just showed, use the buffering model, use minimum buffer time, which is the buffer in units of time, defined by the dash manifest. The second thing, you can provide additional site information beyond the URLs to your client. So since the very beginning of Dash, you had the index files there, same as you used to have in old VOD servers. Index segment is either a sidecar or a part of your larger segment, and it contains just an offset and a duration for each segment. So when you download this, you already know segment A has this effective bitrate, segment B has this effective bitrate, and you know what you can and what you cannot sustain, and how do you need to schedule your downloads so that you will not run out of your client buffer. By the way, if you go and do several resolutions of constant quality, you can, if you know that you cannot sustain a peak, let's say 1080p, you can go to 720p and rely on the fact that your TV probably does decent upscaling, and keep the quality roughly consistent. You can go one step forward, and it's a more recent development. You can specify a quality metric for a segment. So you can say this segment has score X. This is going to be a separate and separately downloadable track that can be referenced in the Dash manifest. If you know this information, then you know to which degree it matters which representation does your segment come from. If, for instance, PSNR is simpler, if you have something that has 45 dBs and 43 dBs, you are better off going for 43 and less bits. The other interesting addition that just arrived, I think, last year, formally, is decoupling switching and random access. If you are going for longer segments, let's say 10-second segments, both your tune-in and your random access are going to be at this granularity. However, if you define your random access unit as something smaller and still addressable, but you don't intend to do the switching at this granularity, you're in a slightly better state here. So on the client side, it's just you plan ahead and use the site information that you are given. So pay attention to the buffer. Don't assume that all segments are created equal. If you have information about the upcoming segments, please go and think how you schedule them. And if you have quality and segment size values, use them. So this is a very short version of the recommendations how to do this. And then I know that we cannot do promos, but I still had to. There is a workshop that is going to be in Amsterdam mid next year. That is going to be concentrated around adaptive streaming, everything around adaptive streaming, and you are most welcome both to attend and to submit papers to it. We'll be glad to see you in Amsterdam. Okay. Questions? Thank you.
Yeah. Thomas Edwards from Fox. So are those quality metrics actually standardized in MPEG DASH right now?
MPEG DASH standardizes the way you can reference them. So this is called association. And then MPEG B 23001 part 10, I think, standardizes the actual format and several of the more popular metrics like PSNR and SSIM. And you can obviously carry a different metric, so nobody prohibits you from carrying SSIM plus score instead.
Hey, Alex. Did you do similar research with HEVC, and did you see any differences in how that behaves?
Our paper will have the HEVC results as well. One of the reasons for X264 is that it's something that is right now more frequently used in production, and it runs much faster.
But did you see any?
And it runs much faster if you need hundreds of reruns.
That's true. But did you see any differences in behavior in terms of variable bitrate versus constant bitrate and quality and so forth?
So I've seen that both behave well.
Similar behaviors, you're saying?
Yes.
Okay.
Questions? No line.
Okay. Thank you so much.